Greetings, this is the second of these here patch a day experiments. Today I'm going to make something which is a plucked string, which you could possibly call a physical model or a physical modeling instrument. It's going to sound a bit rubbish, but that's very cool. So we're going to use a comb filter to do this. We'll type in comb and we'll see that there's a comb object. Since I can't really ever remember what the arguments for a comb filter are, I'm going to just copy them from here. I could look at this, but I'm going to forget that every time I make a comb object, so I'll just copy those arguments, copy the whole thing if you like, and then just paste it in here to get those arguments up. We're going to want this last, I do know that this last argument in the comb filter, the fifth, is it? Fifth argument is the feedback coefficient. I want that to be kind of high, so I'll put it on something like, well, let's make it really high, 0.99, which means that 0.99 of the output going internally, though, is going to go back into its input. It's just a feedback thing. Nothing to be too worried about. And the only value we're going to change here is the delay in milliseconds. We'll need to put a DAC on this thing. So I'll put my easy DAC on. And we're going to have some kind of source for this comb object, which I'm going to use a click. That didn't even start right, because that's a comment. So we're going to make a new object, n, and then click tilde, which just produces a single sample click every time you bang it. I mean, we could actually get ourselves a button, B for button, and turn on our DAC and hear what this is like. So this at the moment is a 1 millisecond loop, if you like. So that's the sound of what 1 millisecond with a click going in sounds like. We're going to want to change this delay time. It's possible that we'd want to make this delay time longer than the 15. This 15, the first argument for comb, is the actual maximum delay time. It's possible we'd want to make that longer, and it doesn't really take up any CPU, so we'll stick 150 in there, make our maximum delay time 150 milliseconds. And at the top of this thing, we're just going to produce random notes in a pentatonic scale. Let's see, what part of this should I make first? Maybe I'll make the part that drives the randomness, which is a metronome. And then we're going to want something to turn the metronome on with, a toggle, T for toggle. We're going to make a random object here. This is just for the timing of the metronome. We've seen this before. I think I've got this in one of my tutorials. Some value that's sort of the minimum value, so 100 milliseconds for the minimum. Let's make this random value a bit bigger, so 500 milliseconds. This is just timing, so we take the bang from the metronome, stick it through this random, and then use that to set the metronome time interval. That's just to make the timing a little bit more interesting. Then we can do a random object with 5. This is because it's going to be a pentatonic scale, so we only want 5 notes in this scale. And then to make this actually in some kind of tonality, we're going to take those and multiply those random values by 7. This is going to produce a cycle of fifths. So you'll think in pitches, if this was a C, which I think C, a 0 is actually a C, C, then the next number 1 would be a G, the next number 2 will be a D. That's all happening here in this multiplied by 7, and the next number 3 is going to be an A, and then 4 will be a E, the cycle of fifths. If you don't know about the cycle of fifths, I think you should go and Google that right now. I'm going to keep these all within 1 octave range, so that's what the modulus 12 is about. Keep everything within a range of only, well, 0 to 11, so that's an octave, yeah, well, 1 less than an octave in yeah, you know what I'm trying to say. Maybe you don't, but anyway, and we want a minimum value. Let's give it a minimum value of, let's say, 48. That's again going to be a C. In MIDI terms, I'm talking MIDI now. And so to actually create something that's a delay time, first thing we probably want to do is to turn that into a frequency value, M2F, from this sort of MIDI stuff we've got going on there. And then that's now going to be a frequency, but we need a delay time. And this is a fairly standard operation, which is the reciprocal divide by it's an exclamation point right there, which means divide basically whatever comes, what the number that I'm going to type in here, divide that by the number that comes in the left input. I'm going to divide, have 1,000 divided by the frequency, which should be the period in milliseconds for that frequency. You can verify that and do some maths if you like maths. Probably not many of us do. We probably also need to trigger that click before because this won't make any sound. Actually, I have my DAC still on, not making any sound. We need to trigger the bang from the click here, which we could also just do from this metronome right there. And you can hear the dulcet tones of a very cheap plucked string instrument. We could change the range of the scale here. If I put an I for integer box to change this randomness here, we can see that if we only have like 3, we're basically doing a CGD dance, and then if we put 3, 4, CGD AE dance, all the way to 5. If you make it up to 7, you get the full diatonic scale. It's not the scale of C, but you'll figure that out pretty quickly. It has an F sharp in it, which would make it actually the key of G. Well, that's very good. The other thing we could do to make this slightly more musical, although I think our options are fairly limited at this point, we could use, instead of random, let's just try dropping in here an object called earn, which is a non-repeating random number. The one thing you'll want to do is, when the earn is finished picking out the numbers out of its hat, so to speak, it's going to put out a bang out here saying, I'm finished, thank you. And then we're going to trigger a message from there. So M for message, and I'm going to clear the earn so that it's ready to start picking again. Then I might give it a bang so that I don't miss that value. I don't miss that in the timing. So then it would sound more like this. Okay, that's all about all for that very simple example, and I'll check you in the next time. Bye.